Let's get right into it. Number 9. The Downward Defiance. Imagine building a house, but instead of starting from the ground up, you start from the roof down. That's exactly what ancient Indians did with the Kailasa temple. They carved an entire mountain from top to bottom. It's like they looked at a mountain and said, "There's a temple in there. We just need to remove everything that's not temple." This isn't your average construction project where if you mess up, you can just order more materials. These builders had one shot, one mountain, zero room for error. One wrong chisel strike and the whole thing could be ruined. It's like performing brain surgery on a 164-foot tall mountain while blindfolded. The craziest part is they had to plan the entire thing in advance. Without computers or modern blueprints, they relied on pure mathematical genius. Modern architects look at this place and basically say, this shouldn't exist. It's like playing chess in reverse, where you need to know your last move before making your first one. They removed over 400,000 tons of rock to create this temple. The temple has perfect symmetry. Not almost perfect, not kind of perfect. We're talking phenomenal precision. Modern engineers with all their fancy tools struggle to achieve this level of symmetry. These ancient builders did it with basic tools and pure brainpower. You don't just accidentally carve a perfect temple upside down. Number 8. The Jigsaw puzzle walls of Sacsayhuamán. The ancient Inca built walls with massive stones shaped like puzzle pieces from your worst nightmare. These walls are built with stones so perfectly fitted together that the joints are so tight you couldn't even slide paper through. Some of these stones weigh up to 200 tons. That's like trying to move 33 full-grown elephants stacked on top of each other. They did this without mortar. No cement, no glue, just rocks fitting together with precision that modern engineers are still trying to explain. The stones aren't just flat on the sides where they meet. They've got complex curves and angles that interlock in 3 dimensions. It's like they had an ancient 3D printer, except instead of plastic, they were working with rocks bigger than your house. With all our fancy tools and computers, we still haven't figured out exactly how they achieved this. Modern attempts to replicate their methods on this scale have failed to match their speed and precision. The math behind these walls is so complex that it seems to break the rules of what should be possible with ancient technology. It's like finding out your great-great-grandfather had a smartphone. Some of these stones have up to 12 angles. Try cutting a piece of paper with 12 perfect angles that fits exactly with another piece. Now imagine doing that with a 200-ton rock, using only primitive bronze tools. When Peru had an earthquake, modern buildings crumbled. These walls just shifted, and then settled right back into place. Number 7. Lifting the Unliftable. Baalbek, Lebanon. Home of the largest cut stones in human history. The Trilithon. 3 massive limestone blocks, each weighing over 800 tons. These stones were quarried from a site nearly a mile away, then somehow transported and lifted 20 feet into the air. They fit together so perfectly you can't slide a credit card between them. Even our biggest construction cranes today would struggle with a lift this heavy. We have detailed Roman records about their engineering achievements, yet there's not a single word about how they moved these megalithic blocks. Some experts think these stones were placed there long before the Romans, as the base shows different building techniques than the Roman temple above it. In the nearby quarry, there's an even bigger stone just sitting there. The stone of the pregnant woman weighs an estimated 1,200 tons. That's like trying to move a small destroyer ship over land, uphill. The largest known Roman crane could lift about 7.5 tons. To lift just one trilithon stone, they would have needed over 100 of their biggest cranes working in perfect sync, and that's just to lift it, not even to transport it over a mile. Number 6. The Pantheon's Gravity-Defying Dome. The Pantheon's dome in Rome is an engineering marvel, and we still don't know exactly how they pulled it off. It's survived for 2,000 years. It's the largest unreinforced concrete dome ever built, 142 feet in diameter. You could fit a perfect sphere inside it. The Romans built it without any steel reinforcement. That's like building the roof of a stadium out of Legos and expecting it to hold. The dome has a massive hole in the top called the oculus. That hole is actually keeping the whole thing from collapsing. It relieves stress at the dome's weakest point. The concrete gets lighter as you go up. Heavy travertine and brick at the bottom. Light volcanic pumice at the top. They invented graduated density concrete 2,000 years before we thought of it. The dome is a perfect mathematical sphere. Its height equals its diameter exactly. Try building that precisely without computers. Mess up, and thousands of tons of concrete crash down. They built something 2,000 years ago that we still study in awe, without calculators, computers, or even decimal points. Number 5. The Aperiodic tiles of Islamic architecture. Tiling a bathroom floor with square tiles is straightforward. They fit in a repeating pattern. Now imagine covering an entire mosque with tiles that never repeat their pattern. Not once. Ever. That's exactly what medieval Iranian architects did. They did it centuries before modern mathematicians said it was even possible. These patterns are called Giri tiles. Think of them like Lego pieces, but way fancier. There are only 5 different shapes, but when you put them together, they create patterns that go on forever without repeating. In the 1970s, a mathematician named Roger Penrose discovered that certain shapes could create patterns that never repeat. It was a huge deal in the math world. But then someone looked at these medieval mosques and realized something. These Iranian architects had been doing the same thing 500 years earlier, without computers, without advanced math. Modern scientists have analyzed these patterns using computers and found they follow mathematical principles that weren't discovered until the 20th century. These patterns aren't just random designs that happen to never repeat. They're actually encoding mathematical concepts that we now use to understand the structure of matter itself. That's right. These medieval artists were accidentally discovering the same patterns we find in quasi-crystals, a form of matter that scientists didn't even know existed until 1982. Imagine building something by trial and error, only to find out centuries later that you'd accidentally mapped out the structure of reality itself. Number 4. The Antikythera Mechanism. Back in 1901, sponge divers stumbled upon an ancient shipwreck near a tiny Greek island. Among the usual statues and pottery, they found something that looked like a chunk of corroded metal. When scientists finally took a closer look, their jaws hit the floor. This wasn't just some ancient paperweight. This was a computer from 100 BC. While most people back then were figuring out how to make better spears, someone built a mechanical computer. This thing could predict solar eclipses and track the moon's weird orbit. It's like someone in ancient Greece had a time machine, peeked at our modern technology, and went, I can build that with bronze. The device used at least 30 precisely cut bronze gears. This was built by hand. No fancy machines, no computers to calculate measurements, just some ancient engineer with really steady hands and apparently superhuman precision. The mathematical knowledge needed to build this thing, especially its complex differential gears, wouldn't be rediscovered for another 1,400 years. It's like finding out your caveman ancestors had Wi-Fi. The technology just shouldn't exist at that time, but it did, and it worked. It even accounted for the fact that the moon's orbit isn't perfectly circular. It's slightly elliptical, which means sometimes it moves faster and sometimes slower. The ancient Greeks figured this out and built a machine to calculate it. Number 3. Impossible Polish and Acoustics. The Barabar caves in India are carved from solid granite, but instead of rough stone walls, the surfaces are so perfectly polished, they look like mirrors. These are the oldest rock-cut caves in India, dating back over 2,300 years. The walls, floors, and ceilings are polished to a degree that we would struggle to replicate today, even with modern machines. Surfaces so smooth that when you run your hand over them, it feels like glass. This is granite, one of the hardest natural stones on Earth. The mystery is how they achieved this mirror-like finish using only ancient tools. These caves also have some seriously strange acoustics. If you make a sound in certain parts of the cave, it creates an echo that seems to go on for several seconds, sounds that keep bouncing around with an unnatural length and clarity. Scientists who've studied these caves say the acoustics are incredibly precise. The builders somehow knew exactly how to shape the walls and ceilings to create these impossible echoes. Modern acoustic engineers are scratching their heads trying to figure out how they did it. To get these kinds of acoustics, you need incredibly precise geometry, measurements accurate down to fractions of an inch. These caves were carved over 2,300 years ago, before calculators, before computers, before even basic measuring tools as we know them. Number 2. Hōryū-ji Pagoda's seismic solution, a 5-story wooden tower in Japan that survived nearly 50 major earthquakes over 1,400 years. It seems to break the modern rules of engineering. Most buildings try to be as rigid as possible to resist earthquakes, but the Hōryū-ji Pagoda does something different. It dances. Right in the middle is a massive pillar called the Shinbashira, but this pillar doesn't actually hold anything up. It just hangs there, suspended from the top floors. Imagine a pencil inside an empty toilet paper roll. The pencil can move around freely, but it can't escape. That's basically how this pillar works. When an earthquake hits, the building and the pillar start swaying in opposite directions, canceling each other's motion out. Modern engineers were baffled when they studied this. This 1,400-year-old building was using something we only developed in the 1960s for skyscrapers, a tuned mass damper. Today, we use these in modern skyscrapers like Taipei 101. Only instead of a wooden pillar, they used giant metal balls that cost millions of dollars. The original builders left no blueprints, no mathematical calculations, nothing. They just figured out one of the most effective anti-earthquake designs in history through sheer ingenuity. Number 1. Ollantaytambo's mountain moving math. At Ollantaytambo, ancient builders basically told physics to take a vacation. Imagine moving a 50-ton stone block not just up some stairs, but up a mountain. That's exactly what the ancient builders at Ollantaytambo did. These massive red granite blocks were quarried from a site miles away, dragged across a river, and somehow lifted up steep terraces with absolute precision. The logistical challenge would make a modern engineer cry. The force needed to move just one of these blocks up the terraces would be like trying to push 40 elephants uphill. That's assuming you've got a nice smooth surface. But these guys were working on rough terrain that makes a rocky mountain trail look like a bowling alley. One modern team tried moving a smaller block using traditional methods they thought the Inca used. The block moved a few feet on flat ground before getting stuck. Meanwhile, the ancient builders were moving these things up mountains like they were playing with Legos. The stones aren't just placed. They're interlocked in 3D patterns with cuts so perfect you couldn't slip a credit card between them. Some people say aliens must have helped. But what if the ancient builders just understood physics in a way we've forgotten? We're so focused on using machines to overcome physics. Maybe they found a way to work with it instead. It's like they found a cheat code in the laws of physics, and we're still here button mashing trying to figure it out. That's all for today. I'll be making similar videos in the future. Subscribe to see them.